Thank you. So most people think that an IV line is a routine, it is safe, almost invisible. But to some people, to some patients, that is a ticking clock. So when an IV leads to the surrounding tissues without catching by someone, the result is not a minor complications. It can mean swelling, it can mean burns, it can mean permanent tissue damage. And to the most vulnerable patients, that could be irreversible damage. And this is the reality of IV leads, and this is the harm that Leaksenze exists to prevent. So IV lead is not a rare edge case. In pediatrics, it's been reported to happen to 58%. In oncology, 6%. And permanent injury doesn't wait for the next round of nursing wards, right? So the real problem here is that today, hospitals still relies on periodic nursing rounds, and to the most vulnerable patients, such as neonates and elderly patients, the damage can escalate fast. And when that happens, when the swelling is visible, the damage is already very severe. And when that happens, the cost goes beyond the IV line. Routine hospital stay can involve wound care, it can involve surgical interventions, prolonged observations, increased bed occupancies, distress for patients, family members, and more importantly is the liabilities for the hospitals. The treatment case for a severe case can range in Singapore from about 8,000 to 25,000, of course, including the manpower hours. In a whole healthcare system in Singapore, that approximates to about 200 million. And who is paying that? Taxpayers, you and me. So, Leaksenze changes that. Instead of waiting for a nurse to notice a visible swelling, Leaksenze offers a smart patch that communicates with a wireless reader and alerts the workflow before a small problems become an irreversible damage. The protocol is simple. You apply and you monitor and alert. So in other words, it's AMA. So we are not here, what is more powerful about this is that we are not asking the hospital to change their workflow, but Leaksenze is designed to fit ready into the real world workflow systems and to lift the workload of our overburdened frontline staffs. So the patch has been made, the hardware has been built, HSA approved, and we are ready to pilot test in real life care setting. So we're asking for 500,000 with all these agendas in place. And thank you for your attention today.
Thank you. Now for the Q&A section.
Are you planning to seek FDA clearance or anything equivalent, given that the Singapore market is relatively small?
Yeah, that's a very good question. In fact, it's a huge market in US FDA because in the US, this kind of complication is classified as a hospital-acquired complications, whereby the hospital, by law, has to pay for it. So the damage, the liabilities for the hospitals in US is huge, and this will be typically as a class 2 in the US. That is really on our pipeline. I mean, once we are able to conquer the local healthcare systems, that's where we're going. Thank you.
How much does it cost per patch at the moment, and what's the target price?
Right. That's unfortunately, I don't have that on the slides, but just to give you an idea, a normal IV secure patch currently is selling a few cents. But what we are doing here in terms of pricing strategy is not a cost plus strategy, but we base on a value-based pricing. Just now, I think in one of the slides, you are seeing that every hospital, for example, Changi General Hospitals, based on our statistics, every year they are already spending 60 million of damage costs. So we want to price our solutions based on what is the value that we can bring to the hospitals. So the whole solution comes with a consumable, which is definitely much cheaper. The reader itself, the wireless reader itself, maybe I can show bit. The reader itself is reusable. The patch is the one that's consumables. So the patch itself will be obviously cheaper, much cheaper than the reusable readers and the monitors.
In this particular solution, what is being patented?
Oh, what is being patented is the Leaksenze trademark as well as the IP. So the IP as well as the trademark has both been patented.
Yeah, but what is the IP? Which part?
Okay. It's the strain sensors. If you can see, that is that carbon ink that is printed by screen printing on the polyurethane medical dressings. There's a know-how to how to do it in the right way. What is also being patented is also the wireless design that helps the reader to communicate wirelessly with the strain sensors, as well as the application of it.
Just one last question for myself. What's the usual cause for ID leakage? Is it non-adherence, and would that actually solve the issue?
Right, so the calculation here is based on the damage caused.
As in, what usually causes it?
Oh, what usually causes it? Typically, it happens a lot in pediatrics as well as patients such as elderly patients as well as cancer patients, because when you're undergoing chemotherapeutic drugs, it actually makes your skin very fragile and thin. Also, elderly patients, we know that the skin is very fragile and the vessels is very thin, so the dislodge of the needles is very highly probable. And neonates, because they're just pulling and wriggling, so that's very high chance of failure as well.